First open the Xilinx ISI, go to File, New Project, give the name of the project. I am giving it to be SPI Master. Click on Next. You can select any of the FPGA families. I am selecting Spartan 3 with XC3S50 device. Click on Next, Finish. Now go to here and give a right click. Click on New Source. Since we are going for Verilog HDL, I am clicking Verilog module and give your file name as SPI_master. Click on Next, Finish. By default this will create this window. Let me erase it all and give a comment on SPI Master. Let me start with module SPI_master followed by SS, nothing but slave select, followed by MOSI, one more stage that I am considered to be done stage, and inputs I need to bother about. So data I am giving _in, followed by clock and reset. Let me declare my ports. Output rich, SS, MOSI, done. Followed by I need to declare my inputs. Input which is of 8-bit, 7 down to 0 I am considering. Data _in, input, clock as well as reset. Now I am going to declare few registers since I need to design a flowchart. 4-bit register, 3 down to 0 count, as well as register 1 down to 0, state. Now I am going to declare few parameters. Parameter ideal initial stage of those states, 2 tick B00. Since we discussed there will be having 4 modes, here I am going to bother about 4 states. 0 state 0, state 1, state 2, state 3. Parameter start, which will be at state 1, 2 tick B01. Parameter finish, which will be at state 2, 2 tick B10. Finally the last state, parameter next, which will be 2 tick B11. Now I am going to sync my devices with the clock signal, always with sensitivity list. Passage of the clock, begin. Initially if reset is high, begin I need to consider all the reset values to 0. 1 tick B0, followed by MOSI, 1 tick B0, done state, 1 tick B0, and a count which I have declared to be 4-bit. So 4 tick B 100, 1000, since the count that will be doing till 8. Finally state to be 2 tick B00. Let me end it. Else begin. I am going to use the case statement here. Case of state. Let me give the label idle, begin. SS is equal to initial 1 tick B0. MOSI as 1 tick B0. Done to be 1 tick B0 again. Count, which is giving a limit till 8, 4 tick B1000. again done. This time one take B0, state with start. I'm going to start state. I'm going to end this with an end. Now let me give my second label. Start, begin. This is my second state. Slave select to B. Slave select to B. One tick B1. Here I am going to use, since I am going to use the count with respect to shift register, I am going to use the same logic here. Data underscore in of count. If count is equals to all ones, begin. Most is equals to as it is. State will be at the finish state. And else state will be start state. Finally, I am going to end it. Now let me go for the third label, finish, begin. Again starting with slave select to be 1 this time. Done. To be 1 tick 1 be 1. Since we are in the last state, here we are going to move for the next state, followed by end, and the last level where we have not declared next state. So begin. This time I am going to done with 0, followed by end. Let me end it with end case, end, end module. Go for the simulation, click on run, save, yes. We got an error here. We are done with the error. We have simply missed here equality operator that we have prefixed now. Let's see its waveform. Click on SPI master, go to the assimilator, click on behavior check syntax. Again click on simulate behavior model. This will create a new dialog box. Here the input signal that we have given is the data in. I am going to force the constant values 0000 followed by all ones. Click on OK. Now give a clock signal, force clock with a leading edge as 1 and trailing edge to be 0 with a period of around 20 units. Click on OK. Initially make the reset to be high. This would reset everything. Now click on run. Give it a break and observe the waveforms. You can observe here the slave select and the MOSI as well as done states are all at 0 state. Now let me reset the value to be low. Click on OK. Again reset this time. Click on run this time. Here you can observe slave select which is getting enabled, where we are going to select our first slave value. We can see its implementation by clicking on implementation. Now go for the synthesis part. Click on view RTL schematic. click on OK. So this is our SPI master, where we are giving a clock signal, reset signal, as well as data input, which is of 8-bit. And these are the different states we have, where this is our final state, which is going to select your slave select. Double click on this will give me a in detail report of the design that we have made. So you can observe the internal view. You can see its report. Go to the project and click on design summary report, and you can see events in the synthesis report. Go to the synthesis report, and you can see here everything regarding this design that we have just made. The total amount of delay required is 6.216 nanoseconds.